Okay guys, let's take a look at these. So what we're going to be trying to do is solve trig equations for the missing angles, and sometimes these are going to be in degrees and sometimes in radians. We're going to want to look at the directions. Something that's going to be new is we're going to have to use factoring in order to solve these. We're going to have to factor first. So on a problem like this where we have 2 cosine squared theta minus 3 theta, 3 cosine theta equals -1, the first thing I have to do is get this set equal to 0. So I'm going to add 1 over here. So I'm going to have 2 cosine squared theta minus 3 cosine theta. I'm going to bring the 1 over. All I'm doing is getting that set equal to 0. The reason I want to do that is because now this becomes this kind of a problem. This problem right here is the same thing as like 2x squared minus 3x plus 1 equals 0. If you know how to factor this problem and solve it, then you know how to solve this problem. If we were trying to factor this problem, we'd set up our double parentheses, and we'd look here first. What times what gives us 2x squared? 2x and x. What numbers multiply to give us 1? 1 and 1. Okay, well that's going to be the same way we do this. So I'm going to set up my double parentheses. I look here first. To get 2 cosine squared theta, I need 2 cosine theta times cosine theta. 2 cosine theta times cosine theta, that's 2 cosine squared theta like we need. Now I look here. What are numbers that multiply to be 1? So 1 and 1. When I check the outers, I get the 2 cosine theta. When I check the inners, I get a 1 cosine theta. When I combine those two, I'm trying to get -3 cosine theta. So what do we need the signs to be to get a -3 when we do the outers and inners? I want to get -3 of these. So what do I need the signs to be to get -3 of them? Negative and negative. So that's a negative and that's a negative. So once I have this completely factored, now I know that one of those factors has to be 0. So I know that either that has to be 0, so we're going to set that equal to 0. So it has to be the case that either the 2 cosine theta minus 1 is 0, so we're going to do 2 cosine theta minus 1 has to be 0, or cosine theta minus 1 has to equal 0. How do we solve this? What do? We've got to get cosine by itself, so we're going to add 1. So I have 2 cosine theta equals 1. Now what? Divide by 2. So cosine theta has to equal 1/2. Look back at our directions. Find the answer in degrees over 0 to 360. So we're looking between 0 and 360 such that we get 1/2 is our answer. If you are a unit circle kind of person, you can go to your unit circle that hopefully you have memorized. And like I said, you will get a copy of that you can fill in on your own. But we would be looking on the unit circle for where it is that cosine is 1/2. Now what's cosine the same as? X. So can you see on the unit circle where x is 1/2? Where is it? 60. And where else is x 1/2? 300. That would be our answers, 60 and 300. If you don't know the unit circle, then you have to do the triangle thing. You're going to have to say x is 1, r is 2, this is radical 3, it's a 60-degree reference, so it's 60 degrees, and then cosine would also be positive in the 4th quadrant. Another 60-degree reference, so 360 minus 60 is 300. So that would be the answer to that. On this part, I have to add 1, I get cosine theta equals 1. Looking back at the directions, I have to be between 0 and 360, but I'm not allowed to use 360. I can only use 0. So what do you think this answer is going to be then? Where cosine would be 1. What's cosine again? X, Y, what? X. So where is x1? At 0. And that would be our third solution. 0 degrees, 60 degrees, 300 degrees. Okay? If I wanted to use a calculator to check, I could do this. I can do second cosine of 1/2. And I'm going to make sure that I'm in degrees, and I am. And it's only going to give me one of the answers, though. It's not going to give me the other one. I have to know enough to figure that out. And if I do my second cosine, because I'm looking for an angle, so it's second cosine of 1, and it tells me the answer is 0. But this would be on the non-calculator part. Okay, but you can check with the calculator. All right, let's look at the next one. We have 3 tangent squared theta minus 1 equals 0. This would be the same problem as if I were just doing like 3x squared minus 1 equals 0. If we're solving this for x, what would we do first? Add 1, and then we would divide by 3, and then we would take the square root. That's what I have to do here. So I'm going to have to add 1. I'm going to have to divide by 3. And now we're going to have to take the square root. So we're going to get tangent theta equals, what do I have to put when I take a square root? Plus or minus. So I'm going to have plus or minus, what's the square root of 1? Square root of 3 I can't do. And I'm just going to leave it like that. I'm not going to rationalize it. It's easier to see like this. Which quadrants are going to have tangent positive or negative radical 3? All of them, right? What's tangent in terms of x and y? Y over x. You have to know that. I'm going to go ahead and use triangles on this one. You could use the unit circle, but I'm going to use triangles. This is 1, this is radical 3. At some point, if you're going to have to memorize, oops, that's 1. Because y is 1, x is radical 3. So what's the reference angle then? What's across from the 1? In a 1, radical 3, 2. What's across from the 1? So this is a 30-degree reference. And I need 30 degrees in every quadrant. Figure it out. What would it be in every single quadrant with a 30-degree reference? Josh, second quadrant, what would it be? It's 30 degrees, it's 180 minus 30.
Oh, 150.
What's it going to be in the third quadrant?
210.
And in the fourth quadrant? Those are going to be the 4 answers that we get. If we wanted to use the calculator to check, I would do, what do I push when I'm looking for an angle? Second. So I do second tan of 1 divided by radical 3. And it gives me the reference angle. It's 30 degrees. Okay? If I wanted to use the unit circle, I'm looking for y to be radical 3 over 2, x to be, y to be 1/2, and x to be radical 3 over 2. Because I can ignore the 2's. See how that's 1 over radical 3 with that 30-degree reference? 1 over radical 3 y over x. Okay? Okay, let's keep going. So, at the top we were asked to find all the angles in degrees. Now we're being asked to find them all in radians. Okay, so we want to get this solved. What do we always get a set equal to first? 0. So I'm going to add 2 secant theta to both sides. So when I do that, that's going to be 0. I started with secant theta, cosecant theta, plus 2 secant theta. I can't add these because they're not like terms. So I just have to keep them separate. What do we look for when we have two terms? We always should look for a what first when we're factoring? GCF is what I should always look for first. What do these two terms both have in common that I could factor out? So I'm going to factor out secant theta out of each of those two terms. If I factor secant theta out of this term, we're going to have cosecant theta. Plus, if I factor secant theta out of this term, what am I going to have? Just 2. Once we have it completely factored, now we're going to set this equal to 0. And we're going to set this equal to 0. What is secant in terms of x, y, and r? Or actually, let's take it into cosine first. So if I have secant theta is 0 over 1, what would cosine theta be then? 1 over 0. Cosine is r over x. Or, sorry, cosine is x over r. Cosine is x over r. What does the radius always have to be on our unit circle? Is it ever 0? Is the unit circle ever have a radius of 0? So this right here has no solution to this part. This is impossible to have. I can never have a circle where x has a value of 1 and the radius is 0. That's impossible. So this part I don't even have to solve. But I want you guys to solve this part. Keep going with it. And also look at what it says. This time we have to be in radians between 0 and 2 pi. Allie, do you think you know it?
11 pi over 6 and 7 pi over 6.
Anybody want to second that, or do we disagree? Good. We have a lot of seconds and thirds. That is correct. Very good. If you had 210 degrees and 330 degrees, you are in degrees and not radians, and you need to convert. If I wanted to use the unit circle here, if you can just, recreate that, I'm looking for where y is going to be -1/2. That's right here at 11 pi over 6 and 7 pi over 6. But of course we can't just, whip out a unit circle when we're in the middle of a, calculus class. That's why you have to get to where you can visualize that unit circle, or you can visualize triangles and you can get these answers without having to sit there and stare at the unit circle. Okay? All right, let's do the last problem here. This is the last one we're doing for today. We want to solve this. Okay? So we have to get a set equal to 0. What are we going to do to both sides? Subtract 1. So we're going to have, that's going to cancel, negative tangent squared x plus tangent x equals 0. Now, this problem, even from right here, looks a little weird because this says x. It's still the same thing as theta. It's just we're using a different variable. This does not mean like x on the unit circle or anything like that. It's just now we're representing x as the theta value. Okay? So don't let that confuse you. I have two terms. Anytime I have two terms, I'm going to look for a GCF. What is the greatest common factor for those two? Tangent. So I'm going to factor out a tangent. And after tangent, I have to have whatever my angle is. My angle in this case, we're just calling it x, the unknown. So what is negative tangent squared x divided by tangent x? Negative tangent x. Good. And then plus, what's tangent x divided by tangent x? 1. So now I have it factored. Once we have the equation factored, we set tangent x equal to 0, or we set negative tangent x equal to, or plus 1 rather, equal to 0. I'm just setting that equal to 0. So this one is already solved, but this one I would have to subtract 1 and then divide by negative 1. All right, now remember, if this gets confusing, if you don't like this being an x, just change it to a theta if you want, if you don't like thinking of that as an x. It's just the unknown, okay? What is tangent on the unit circle in terms of x, y, and r? Do we know it? Here's how you do it. SOHCAHTOA. You go all the way back to this if you don't know it. H is the same thing as what? The R. Alphabetically, A comes first. That's X. Y alphabetically comes after X, and O comes after. That's Y. This is Y. This is X. So what's tangent? Y over X. So this is Y over X. This is Y over X. You guys solve it now. I'll tell you that you should get 4 answers. Timothy, you look like you've got the answer. What do you think?
You said 4 answers?
4 answers.
Pi over 4. 3 pi over 4. 5 pi over 4. 7 pi over 4.
Okay, I agree with 2 of those 4 answers. Anybody want to make a change? Ian?
I have pi over 4, 5 pi over 4, 0 and pi.
What do you guys think? Yes, this is correct. Timothy, you were thinking in all quadrants with a 45-degree reference, but that would only be if this had been tangent x or tangent theta equals plus or minus. So for this one, I have to either be in quadrant 1 or 3 because I have to have y over x end up being a positive 1. So it could be here or it could be here because a negative divided by a negative would give me a positive. The other 2 answers came from this, y being 0. There are 2 places on the unit circle where y is 0. It's at 0 and pi, and that's how we got the other 2 answers. Okay? Any questions over that? How many people got that one right? Okay, about half, not bad. We need to get 100% on that. Okay.